Und wir machen weiter mit Dr. Torsten Musiol, CEO von MECSware. Und ja, er hat auch ein bisschen was mitgebracht, wird so ein bisschen was zeigen. Und sein Thema ist 5G Network on a DIN oder DIN Rail. Und ja, sein Vortrag wird auch in Englisch stattfinden und the stage is yours. Bitte schön.
Ja, vielen Dank für die Einführung. Yeah, many people think that 5G is very, very complex, very, very difficult to handle, very difficult to manage, very expensive. And MECSware is there to prove that's not the case, or it does not need to be the case. So what I'd like to show you today is a campus network in operation. I will show you a live demo. And it's, as we see here, very, very compact and very, very easy to handle. If you think about a campus network, 5G campus network, you probably think about, first of all, a server rack, 19-inch rack, multiple servers installed there, interconnected, and so you need 3GPP experienced engineers to get it running. And it does not need to be. What you see here in this box, this is a complete campus network. It contains a core that is running in a small server device here at the bottom, and it contains a 5G small cell here, and that's all what you need. So you can get started with a very, very simple setup just to try out the technology is good for you, and then later on, if you made the decision that it does, then you can increase the network and build a large deployment. I'll show you later on how that works. But first of all, a few words to get the context about the solution as such. If we look at 5G campus networks, they are not all the same. Although the architectures are not the same, the deployment models could be different. And first of all, there's a big difference in how the functionality is distributed. If you consider functionality what might be in the cloud on the internet, and functionality that should be then locally on site on premise here. And looking at the left-hand side, wireless LAN, I come to that later on, while that is our role model. You see, everything is on premise, everything is installed there. It's easy to handle, easy to manage all the functional layers, service management, network management, user management are completely under control of the user. There's nothing in the cloud. Everything on premise. On the other hand, if you build a campus network, what's certainly doable using a public network, then probably you have your smartphones and your routers, your end-user equipment under your control, but all the rest is then managed by the public operator. And there is something in between, what I called here is a partially private 5G, 4G network, campus network, with a so-called vendor cloud. There is some functionality on premise, what you can completely have under your control, and there's some functionality outside on cloud, what you have less control of. And we decided when we developed our solution to make exactly how wireless LAN or well-known wireless LAN networks are built. Everything is on premise, nothing on cloud. There's no internet connectivity needed for that. That's the approach. Second, we look at the architecture, how to build radio access networks, the RANs. And this architecture shown here on this page is a well-known architecture deployed in the public network. So basically, all public networks are based on that paradigm. You have a so-called baseband unit that is most often built on a DSP or digital signal processing basis, running very efficiently. The high performance and high processing requirements for the radio processing, for the modem functionality in the public networks, and then is a remote radio head or a remote radio unit. It's connected then through a fiber, to a high-speed connection, and this radio unit can be then installed on a mast, on a pole, or wherever, and the connectivity between both is called it's named called front haul. I show later on why it's front haul, because there's also a back haul. And the specifics on this front hall connection is you need to have a very, very high control on that. It demands a high capacity, and it's very, very sensitive regarding latency and jitter in particular. So that means most often this front hall connection requires dedicated fiber. So I mentioned also the backhaul. The backhaul is then the connection to the core, and of course all architectures have this backhaul connection. Now, what happened now in the last few years? Everyone has heard about Open RAN, which is the concept basically, and ORAN, what is a set of specification driven by the ORAN Alliance. And what is this architecture all about? First of all, what are the drivers for that? The drivers for that is where to make radio access networks more vendor independent, and to run functionality on commercial off-the-shelf servers, and do it then through virtualization or softwareization, to running then modem functionality, what was used to be in the baseband unit, running that on commercial off-the-shelf servers. The architecture, the so-called 7.2 split, is so that some central functionality are running on a central unit, so the name gives it directly, and then some functionality, particularly regarding the radio functions, is running on a distributed unit. And now we don't have only the front hall and the back hall, we only have a mid hall. So this architecture is going to be even more complex and complicated. And also regarding the initial target to run everything on commercial off-the-shelf server, it's not likely that, if you look into real deployments there, because people found out it takes a huge number of CPU cores to run distributed unit functionality. You need a huge amount of processing capacity here. And then they found out, okay, not even the most powerful server with, I don't know how many enemy cores can do it. Let's put extra hardware functionality into that. That is built on field programmable gate arrays. So that's a hardware accelerator card needs put into that. And then you might get the throughput that you need. But, well, the initial target to have a commercial off-the-shelf completely independent of the hardware, that's gone, right? In a way, it's again a very, very specific hardware. And on the front hall side, all the requirements that you have here on the legacy architecture, they remain. It has to be high capacity. It has to be very, very jitter sensitive and well controlled. Dedicated fiber here. Everything is, in my understanding, with the so-called disaggregation, it gets even more complicated. But there's an alternative, and that's what we are doing here. Otherwise, I couldn't show it here. It's a very simple setup. The alternative is very simple. You have everything of the radio access networks, everything contained in one single box. And this single box contains a SoC, a system on chip. So it's a very, very specific chipset, like in Wi-Fi, like in wireless LAN access points. That's then the way to make these 5G networks as compact as Wi-Fi already is today. And well, what's the other way than disaggregation? It's aggregation in a way, right? Everything, the CU, DU, RE functionality are integrated in one single box. And another benefit of that is we don't have the front hall anymore, so we only have the back hall. So that means the only user traffic, almost a little bit of control traffic from the core is running there, but there's basically this connectivity, this backhaul is only driven by user traffic requirements. So you don't have the high capacity requirement anymore. You don't have the synchronization, sensitivity regarding jitter anymore in that respect. If you have, for example, here an outdoor base station with integrated GPS receiver, all synchronization is completely self-contained here in the box. So this simplifies the deployment very, very dramatically. Now, how we do it? I already mentioned the SoC, the system on chip. And yeah, we are using system on chips from Qualcomm, and that's also a good choice, because Qualcomm is providing also SoCs for the user devices, for the smartphones, for the routers, and having done a SoC from the same company on both ends, yeah, that makes it easier, or it simplifies interoperability issues, or to handle these interoperability issues significantly. That's what we found. So that's the way how the system is built. Now, I mentioned Wi-Fi already several times, the wireless LAN architecture several times. The Wi-Fi architecture, that is our role model. It's well known to everyone, and everyone understands what is needed. You need, for a larger Wi-Fi network, a controller, you need an Ethernet LAN, and then you just connect to the Ethernet LAN your Wi-Fi access points. And today in a presentation from Siemens, or you heard the statement, well, it should not take more than an hour to set up a Wi-Fi network. And even the reference to Fritzbox has been made. And that's exactly the case here. So I'm showing that it's not more complex or more difficult to set up a 5G network rather than a Wi-Fi network. So, architecture, I said, controller, LAN, access point. The same thing here. Our controller, that is our MECS, is a mobile edge cloud server. We'll come to the point mobile edge cloud later on anyway. That includes the core network. It's connected to an Ethernet LAN, and you simply connect then your 3G, your 4G or 5G. Actually, both are supported by the same solution. Can run even in parallel. So we can run even in parallel a 4G network with a 5G network. I show it here. You see here, this is a GUI. There's a 5G network part and there's a 4G network part, can run in parallel. You simply connect the access points to the Ethernet, and that's it. I mentioned already the GUI. Yes, everything is manageable through a GUI. All the different network domains, the core networks, the radio access network, and the user equipment. I'll show it in a demo later on anyhow. And there was a question about APIs this morning. And yes, it has this API. So everything what is possible to be done through the GUI can also be done through a RESTful API. Now, come to the demo. And already introduced this box here, what is our campus network. That is connected then here on the management interface to my laptop. And the radio network interface here, this RNI is an Ethernet cable to the small cell. And then we have two end devices. This one here. That's ordinary smartphone. And then our MECS IPC, that is an end device, a router device developed by MECSware. So that's, you see the similarity of this box with the server here, because it's based on the same hardware platform. So very handy, very easy, and why we are doing that? Because we found for a number of research, because we are participating in many research projects, that it's very good if you have a user device under your control where you can develop software completely to implement a special function that we need then for certain research projects. Now, let's go to the demo. Okay, so here we go. No. Why it doesn't show? Okay, probably the full screen mode has prevented that. Okay, here we go. That's our MECSware campusXG dashboard. And in this setup here, I only have a 5G network installed. As I said, already 4G can run in parallel. And yeah, what do we see here? First of all, it has a platform, yes. It's a virtualization platform. I'll come to that later on. And it has then the different entities or the different tabs here for the different network domains. Let's look into the core network. Not much to configure here, very, very simple. The network name, the country code, the network code, then you can set up slices here if you wish. There's only one slice at the moment. You configure the UE IP subnet, and you can even allocate your UE IP addresses through DHCP if you wish. I don't have it at the moment running here, but it's statically configured. Looking into the base station, yeah, we have two base stations configured here, one indoor small cell and one outdoor small cell. The outdoor base one is at the stand over there, so I didn't put it in here. At the moment, only the indoor is connected. As you can see, we can configure the cell. It's now uploading the configuration from the cell. And so all the relevant parameters can be easily configured. In particular, the band. So we are using here band 78. That is the band what we got this 100 megahertz allocation from Deutsche Messe for this event here. So we have allocated 60 megahertz of this 100 megahertz to the 5G network because there's another network running here over there. If you have recognized that RS Connect, the company next to the MECSware stand, is running another network. So DESOC has got allocated 20 megahertz. So in order to keep this a little bit separate, I had now a guard band of 20 megahertz. So this one is then running with 60 and not with a full amount of 100. But of course, it can. So if you go here, then you can select all those 100. Downlink uplink ratio can be configured. Multiple ratios possible. 4.1, that is the one that's more downlink optimized. And 4.5.5 is the one more uplink optimized. You can adjust the TX power, the transmit power, and the sync type is free running at the moment. Of course, also GPS and PTP are supported. So that's the base station. Now, looking into the user equipment. So what we have here, I already said, that is the phone. This is our ASUS phone. That is IPC, Max IPC is our router device. And yeah, both are for both user equipment we have available the monitoring. So you can enable that the round trip type should be monitored. I will show you how that will work, and same here for the IPC. And this is using the idea or the concept of MEX apps. So MEX apps are functions that are running on top of the MEX platforms. As I said, it's an MEC. It's an MEC device, mobile edge cloud, mobile edge compute device. You can run functionality right on the server, co-located with the core. So no data is leaving the box. You can make it completely self-contained. And I've installed now two MEX apps here. One is a performance monitor, and one is a log management system. So the performance monitor is Grafana based. Let's make it a little bit smaller here, so you can see here. And what you can see here is a ping monitoring, so round trip time of both devices. And for the router here, you see here this usual 10 to 12 milliseconds round trip time that you normally get. With a smartphone, it's a bit more, so that's around about 50 milliseconds. You see it's not the same. Explanation for that would be that the ping response here in the smartphone operating system is not that fast as it is here on the router device. Otherwise, radio technology is the same, and yeah, that is my explanation for that behavior. And if I would switch this off, can put it into flight mode. You see here the red dots at the bottom. It's the top diagram. They indicate there's a packet loss, so that means no connectivity anymore. And if I switch it on again, no. So now it should be back again. Yeah. All right. So first spike here in the ping time is because of the attachment. So it has to reattach to the network, and therefore the ping time is higher. Okay. That's network performance monitoring. what else can we show here? You might have recognized that this is the router device is tagged here as managed. We can have here a button where we can set this managed mode on or off. Now it's managed means we can remotely control this device here from the same dashboard. Okay, I can do it now. So I click on the link, and ta-da! Now I'm on the router device. You see here it's the same platform, the same platform as we have seen before for the MECS itself, but it's obviously less items here. You can, for example, look into the network parameters. So it says here an RSRP -47. That's of course very, very good because it's right in front of the small cell. You see here the network code and the country code, and yeah. But the tricky thing here also is this has the same platform as a mobile edge cloud server. So that means you can also install virtual machines. So it's again an intelligent device what can perform edge computing on the user equipment. So that means even further closer to the sensor or whatever the source of information is. So you have MEC functionality on the user equipment, and you have MEC functionality on the server device. All right, that's about the demo. I guess now we are back to our slides. Hopefully that works now. Yes. Okay. But now, what about DIN rail? What about DIN rail? And that's it. That's a campus network on a DIN rail. So see here, the same MECS device, the one that I showed you here inside. It's just installed on a DIN rail. And user application could be, for example, this one here. You have a factory hall, and most data is really local. Most data has a local context. So solution could be you do not run your data outside of the factory hall. Everything is contained there. It stays local, and you can even process all your data as MECS apps running here on the platform. Of course, you can also break out with the Ethernet to go to a server nearby or to in a data center if you wish. But at least you have the capability to do much processing close, even much closer than to the end device as you would have with other architecture. All right, finally, if you think that's the only way to build campus network MECSware, no, of course they are scaling up, and you can build also the same software running on 19-inch servers, even multiple of them to increase capacity. You can have indoor-outdoor cells, user SIM cards, and then what I already mentioned, the functional extension goes through the MECS apps were installed as application on the server. And that concludes my presentation. I hope you got an idea how small a network can be built. And now I'm open here to get your questions. Auch in Deutsch gerne.
Okay, thank you very much. Thank you for this demo. Quite impressive. And yeah, are there any questions? Gibt's Fragen? Ja.
First of all, thanks for the nice demo. You were talking about RESTful APIs. Did you implement already network exposure function?
Could you please explain network exposure function?
Yeah, that is basically to control quality of service.
Ah, okay. Yes, we do.
From outside of the network.
Yeah, exactly.
Yeah,
exactly. So almost everything what you can do through the GUI, you might have recognized on the user page there was also a tab QoS profiles. I don't know if you have recognized that. Almost all functionality what you can on the GUI is exposed on the API. So you can control the QoS profiles and assign them to user equipment if you wish. Or you can even manage the profile as such, so you can change the profiles, activate and deactivate and so on.
Okay. Any other questions? Gibt es noch weitere Fragen? Gut, Herr Musiol, dann bedanke ich mich nochmal für die Demo und auch Sie stehen ja jetzt auch nochmal dann im Nachgang, denke ich, zur Verfügung oder in der Kaffeepause oder wie auch immer.
Ja, klar.
Gerne. Super. Dann, Herr Musiol, vielen Dank nochmal.